Today we're doing 4.3a. We're going to add, subtract rational expressions, and just want you to also write in here that you're doing 1 to 15 on the worksheet for this portion of it. Okay? Don't need to do beyond that. Tonight we'll do the rest on Tuesday. When do you think you learned how to add fractions? What grade would you have been in?
Elementary.
Elementary? Third grade? Really? That early? Okay. So when you learn to add something like, say, 1/2 plus 3/5, how did you learn how to do that? Obviously, what do you have to do to add this? What do you have to get? Got to find a common denominator. So how did they set it up? Did they have you stack it vertically and then get common denominators, or how did you learn to do that? What'd you do, Savvy? Like this, right? You set it up like this, plus 3/5, that type of thing. And then here wrote a common denominator. Okay. And then how did you find your common denominator? Did you always just multiply the two together, 2 times 5? Or what if it was like 6 and 12? How did you find that common denominator? Okay, times by 2 and then do it again. Okay. So obviously the common denominator here would be 10. Now again, what we're going to be doing, you guys, is generalizing this. All these rules still are the same thing, but I want you to think through what was the procedure, because you're going to do the same thing when we throw in letters. Okay? But what did you do here? Well, you figured out what did you multiply the 2 by to get 10, right? And if I multiply the denominator by 5, I also have to multiply the numerator by 5. Multiplying by 5 over 5 is really multiplying by 1. Anything times 1 is equal to itself, right? Okay? So, but then you just multiply this and you got 5. So you knew those two things were equivalent. And you've done this for so long, you look at 5/10 and you know that's a half, right? Okay, same thing here. What did you multiply this 5 by? You'd multiply it by 2. That means you got to multiply the top by 2. Okay? That procedure we're going to do that exact same thing, okay? Multiply, you're going to figure out what do I need to multiply by. It's just going to look a little different because we're going to throw in variables and they're going to have parentheses, but it's the exact same thing. And then you just added the top, right? You added the numerators and you kept that single denominator the same. In fact, I could have written this as 5 plus 6 over 10, right? And then added those. Can I reduce that 5 and that 10? Can I reduce it right here and make it 1 over 2? No, can't do that, right? The 5 and the 6 are tied together with that addition sign. That's not legal. Okay, this is how we're going to approach it. This is what we have seen on their SBAC release questions. They will set it up, they'll put a big fraction bar, and whatever the common denominator is, they'll just put it down here. Okay? And then what you're going to do, you guys please. You're going to take whatever's on top here, and then you're going to see some problems where they put this box, but we're just going to open a parentheses, and you're going to look at this. Okay, this 2 is now 10. What did you do to the 2 to make it 10? You multiplied it by 5. You have to do the same thing to that 1. So we're going to put the 5 there. Whatever this sign is right here, we're going to put plus, and then we're going to write this numerator down, open a parentheses, and figure out what we need. Okay? 5 times what is 10? 2. So that means you need to multiply the 3 by 2 also. So notice what we've done here. Just in one step, we've written this part. We've done the 1 times 5. Okay? We wrote this part. We're doing the 3 times 2. It's the exact same thing. It's just presented maybe in a little different format. And again, you're getting here 5 plus 6 over 10, which is what we knew was the right answer. Okay? So we're going to extend this now to letters, throwing in variables. Okay? Let's start easy first. If you have add or subtract, the directions are going to be to add or subtract and then simplify. Again, you don't have to state any excluded values for these. It just gets a little bit too much to try to handle. Okay, so let's start really easy. Let's take something like 10a over 3a minus 4 plus 2a over 3a minus 4. Okay, so throwing in letters. The key when adding fractions, adding rational expressions, is you have to have common denominators. We've already got it. We got the common denominator, right? So when you're adding, all you then end up doing is add the top, right? So what's the answer to this? 12a over 3a minus 4. Can I cancel the 3a and the 12a? No. That 3a and the minus 4 are tied together. You have to cancel the whole thing. All right, that's it then. That's just your answer. Just add the top. Okay, let's go a little bit more complicated than this. Let's take 3 over 7y to the 4th plus 2 over 3y squared. Okay, so the problem with this right now is we don't have a common denominator, right? So we got to get a common denominator. Now I want us to do it like this problem right here. Okay, so I'm going to set up an equal sign, I'm going to put a fraction bar, and I'm going to figure out my common denominator. You got to look at both parts. What do both 3 and 7 go into? The smallest number that they both go into, it's their least common multiple is what it's called. What is it? 21. Okay, then between y squared and y to the 4th, y to the 4th is enough. Okay, y squared goes into that. It divides into that. Okay, y squared wouldn't be enough, because y to the 4th wouldn't go into y squared. Okay, so if you have an option between like a y squared and a y to the 4th, just take y to the bigger power, whatever that is. Okay, and then, so write the 3 down and open a parentheses. Now we're going to figure out what do I need to multiply that 3 by. Now here's how you do this. You compare the 7y to the 4th and the 21y to the 4th, and you figure out what did I multiply this by to get this. What did I multiply it by? And I see the y to the 4th is the same. 7 became 21, so what did I multiply by? 3. That's what you're going to put in parentheses here. Okay? Because I multiplied this by 3, I need to also multiply this by 3. Keep this same sign. Put the 2 there. Okay? And then you're going to compare this. To go from 3 to, open a parentheses. To go from 3 to 21, I need to multiply that by a 7. But I also need to go from y squared to y to the 4th. What else do I need? Another y squared, right? Isn't that what I would multiply this by to get 21y to the 4th? Okay, then go ahead and multiply that out. You get 9 plus 14y squared over 21y to the 4th. Am I able to reduce anything from this? Can I simplify that at all? No. There's nothing that I can take out. That's your answer. Okay? I want to do another one that's kind of like this. Number 3, 4 over m plus 2 plus 6 over m minus 1. Okay? The only way you can add fractions is if you have common denominator here, and m plus 2 and m1 minus 1, they don't share any common factors. The way you would know is if they had been stacked in a fraction, could you reduce anything? No. Okay, so they don't share any common factors. That means you need each of them in your denominator. Okay, so set up a big fraction bar. Put both of them in parentheses in your denominator. I need them both. So it's like the problem up above that we did where you multiplied the 5 and the 2 together to get 10. That's what I'm doing. I'm multiplying those two things together. Okay, then I'm going to come back in this numerator. I'm going to put a 4 and I'm going to open a parentheses and I'm going to figure out what is missing. And this is what I'm comparing. This m plus 2 with this. The m plus 2 is there. This isn't. This is what I multiplied by. I also have to multiply that to the top. Okay, so I'm going to put m minus 1 right here. Plus 6, open a parentheses. Look at the denominators here. Under the 6, there already was an m minus 1, not an m plus 2. That's what I need. Can I cancel this m minus 1 and this m plus 2? I cannot. What ruins it? Why can't I do that? There's something in this problem that ruins it. That plus sign right there. If you have a plus outside of the parentheses, you can't reduce. Okay, so don't be tempted to cancel those. You don't want to do that. You're going to go back to where you were. Okay, instead distribute. Okay, so distribute this. Getting 4m minus 4. Distribute the plus 6. So plus 6m plus 12. Your denominator just stays. Do not FOIL out the denominator. There's no reason to. Leave it factored. Don't risk making a mistake. Plus, if we're going to reduce, we'd want it to be factored. Okay, and then combine like terms. I think we have a 10m and a 8 plus 8, right? Okay, then at this point, it's how good are you at mental math as to whether or not you need to take an extra step. I see a common factor in that top, okay? But the question is, if I pulled that common factor out, would I get one of these two guys as the factor? Okay, let's say I don't see it. I'm not good at mental math, so I'm going to pull out the common factor of what goes into both 10 and 8. 2. If I pull it out, what's left? 5m plus 4. Okay, is there anything here that I can reduce? Can I cancel those 2's? But there's 2's in the numerator and the denominator. Why can't I cancel those? They're both there. Why can't I cancel it? Why not? It's tied, right? You gotta cancel the whole thing, m plus 2. Okay, now listen, you guys. Either of these answers are fine. So if you're able to look at the top and say, okay, if I pulled out a 2, I'd have a 5m plus 4. I'm not going to be able to cancel anything. You can leave your answer like that. That's perfectly good. But if you had factored it and you'd been able to reduce, then it would be wrong. If you didn't reduce it. Okay? So far, how are you feeling with this? 1, pretty good. 4, not so good. Can you tell me where you're at so far with only 3 examples? Okay. All right. Okay, let's try this one. Number 4. 4x over 2y minus 6x over 3y plus x over 6y. Okay, so we're going to do 3 terms now. You know, it's the exact same thing. And whether it's addition or subtraction, right? Either way, you got to get a common denominator. Okay? All right, so we're going to do the same thing. We're going to set up a big fraction bar. Now, we got to get a common denominator for all of those. Okay? So let's look at the number part first. 2, 3, and 6. What's the common denominator for all of that? It's the least common multiple of 2, 3, and 6. 6 is good, right? They all go into 6. And then they all just have a y, so 6y should do it. That should do it. All right, so let's go to the first thing. You're going to open up the 4x, write the 4x and then open up the parentheses. Okay, what do I need to multiply 2y by to get 6y? 3. So I need to multiply the 4x by 3. Okay, keep this sign, minus 6x, open up the parentheses. What do I need to multiply 3y by to get 6y? 2. Okay, and then write the next numerator down, open up a parentheses. What do I need to multiply 6y by to get 6y? 1, right? That didn't change. Okay, go ahead and multiply out here. We'd have 12x, minus 12x plus x over 6y. X over 6y would be your answer. That one worked out nicely. Okay, subtraction, just be careful. Just watch your signs is all. If you're careful to bring down the sign, you'll be okay. 3 over x minus 4 minus 3 over x plus 4. Set up a big fraction bar. What's going to be my common denominator here? Can I abbreviate those at all, or do I need each of them? I need them both, right? Okay, so I need an x minus 4, and I need an x plus 4. And again, the key would have been if I had stacked those, could I have reduced anything? And no. Okay, so you need one of each. All right, on the top here we have this 3, open a parentheses. Now look at that fraction, look where we're going. What's missing from here? X plus 4, you got to put it up here. Okay, and then again, just be careful here. It's minus 3, open a parentheses. I have an x plus 4. I'm missing x minus 4. Okay, can you see where we might make a mistake on this now, this next step? Distributing that, right? Okay, so distribute 3x plus 12, and then right here, make sure you distribute the negative 3. So it's minus 3x what? Plus 12. Yeah. All over your denominator. 3x's cancel. Add the 12s. I get 24 over x minus 4 times x plus 4. Can I reduce any of that? Nope. So that's your answer. Okay, so just remembering from Wednesday, if I had 2 over x minus 1, I could switch that and put a negative out in front and make it 1 minus x if I wanted to. Okay, or vice versa. If I had 2 over 1 minus x, I could switch that, switch the sign, and make it x minus 1. Okay, these differ, well, not differ, but if you factored out a negative, either one is the other multiplied by -1. So if I pull out a -1, I could switch them, right? So remember that? Okay, so with that in mind, how would you do number 6? 4 over x minus 5 plus 2 over 5 minus x. They're almost common denominators. They're almost the same, right? The only difference is they're backwards. 5 minus x and x minus 5 are opposites of each other. So if I pull out a factor of negative from either one, I like to do it from the second one, just my preference, okay? So what you can do is pull that negative out and switch the sign here. Since this is plus, we'll make it minus. And then I can switch that around. And then once you have a common denominator, we don't have to get the common denominator here. It's already there. So you just subtract the top. 4 minus 2 would be your answer. 2 over x minus 5. All right, one more. Got it? Gonna kick it up a notch. Ready? You like the notch around it. Okay. 1 over 2x minus 4y minus 1 over 2x plus 4y minus x over x squared minus 4y squared. Really kicked up a notch. Okay, so towards the end they're going to be a little bit more complicated like this. Kind of hard to tell right now what your least common, what your common denominator is. You need to factor. Okay, so when they're a little bit more complicated like this, factor each one. How would you factor this guy? Pull out a 2. Celeste, what would you have left if you pulled out a 2? Okay, and then if I did the same thing here, Ashlyn, what would I have left? X plus 2y. Okay. And then here, I can factor this as the difference of 2 squares, right? So Christina, can you tell me what that would factor into? You guys agree? Yeah. All right, now what we're looking for is the least common multiple that all these things go into. Okay, so set up a really big fraction bar because we're going to have 3 terms here on it. Okay, so I'm seeing that this has a 2 and an x minus 2y. I have to have both of those things. Okay, I only need one of these 2s though. Okay, so I'm going to have a 2. I'm going to have x minus 2y. For this guy, the 2's taken care of, but this x plus 2y is not the same, so I need one of those. For the last, I've got the x minus 2y and I've got the x plus 2y. So this would be my, in essence, least common multiple, my common denominator. All right? We're going to come up here. I'm going to write this one down. I'm going to open a parentheses. And I'm going to figure out what am I missing. This is what I had. This is what I now have. So what do I need? X plus 2y. Then I'm going to go minus 1. Open a parentheses. What's going to go in the parentheses here? Then I'm going to watch this sign, minus x, open a parentheses. What goes in that parentheses? What's missing? 2. Okay, then I'm going to go ahead and distribute everything and get rid of the parentheses. And then on top we need to combine like terms. How many x's are going to be left over? Looks like this x and this x would cancel out, and so we'd have a negative 2x, and I feel like we'd have a positive 2y, positive 4y. Okay. Then at this point you have a choice. If you can do the factoring in your head and can tell whether or not, because we can factor that top, right? What can we pull out of the top? We can factor this some more, right? What does it factor into? Tell we had a late football game last night. Jordan, can you factor the top for me? What 4y minus 2x, what could I pull out?
A 2.
A 2. And what's left?
2y and then minus x.
Good. Okay, and so down in the denominator we have this. Is there anything we can reduce? We can cancel the 2's, right? That's legal now. These 2's right here. Anything else? We can take a negative out of either one of these, right? So since these are exactly opposites like that, we can reduce those, and what we would have done is we would have pulled a negative out, so we cancel those and we just write a -1, right, above the top of that. So all the top is just -1, which again, I could put that negative in front of the whole fraction. And on the bottom I'd have x plus 2y. That's what that all came out to be.